In the last video, we saw instances where we could calculate a definite integral by treating it like a geometry problem and finding the areas of rectangles and triangles and parts of circles and other obvious shapes like that. Sometimes, though, we're going to need to use the fundamental theorem of calculus in order to solve definite integrals. So let's go back quickly and take a look at what the fundamental theorem of calculus says, and we'll see how we're going to be able to use that. All right, so remember the fundamental theorem of calculus says that if f is continuous over the integral ab and big F of x is any antiderivative of f of x, then we can calculate the definite integral of f of x based on that antiderivative. Okay, so that may seem like, okay, well, how do I know an antiderivative of a function? What kind of functions would I know that there is an antiderivative of it? Well, here is some key ideas. So let me break down what antiderivative means. Remember that antiderivative is just the inverse of the derivative operation. So let me write down this statement that I hope you will agree is obvious. F prime is the derivative of f. I hope you agree with that. It's kind of the definition of derivative and the definition of that f prime notation. So here's what I mean when I say that antiderivative is the inverse of the derivative operator. I can say f is an antiderivative of f prime. Okay, this is something that is really, really important. I want you to write this down on your notes in the corner so that you can refer back to it later. I want you to write this on a Post-it note and stick it on your bathroom mirror so that you will be reminded of it day after day until it gets not sticky and falls off the mirror. And hopefully that will be enough information, enough time for this to stick in your mind, that if we know f and f prime, we know that f is always an antiderivative of f prime because it's just what it means to be an inverse, right? All right, let's see where this becomes useful. So I am now on page 506 of the notes. So pictured below is a table of values that show the values of a function f of x and its first and second derivative for selected values of x. Use the information in the table to answer the questions that follow. All right, so what is the value of the definite integral from -3 to 1 of f prime of x dx? Well, in the last video, we were able to calculate definite integrals because we had the graph of f of x. And so we were able to break it down into geometric parts and add and subtract parts of it together to calculate that definite integral. Here we don't have that information at all, but we can use the fundamental theorem of calculus. So we want to calculate a definite integral of f prime of x, which we can do if we know an antiderivative of f prime of x. Do we know an antiderivative of f prime? F is an antiderivative of f prime. F is an antiderivative of f prime, which means that we could just write this as the indefinite integral from a to b of f prime of x dx is equal to f of x, f of b minus f of a. This is just the same thing, except instead of f, big F, being an antiderivative of little f, I am saying that f is an antiderivative of f prime for any function at all. How does that help us solve this problem? Well, so this just says that this is equal to f evaluated from -3 to 1, because f is an antiderivative of f prime. So this is just applying this to the fundamental theorem of calculus. And that's equal to f of 1 minus f of -3, which we can see from this table. f of 1 is -2, and f of -3 is 4. So the value of that definite integral is -6. Okay, so there are going to be problems where we are able to find the definite integral by using geometry like we did in the last video, and there are going to be times when we know the antiderivative instead of a graph of what's in here, and so we can use that antiderivative and the fundamental theorem of calculus in order to calculate the definite integral. All right. In the next video, we will do problems 2, 3, and 4 really quickly because they are pretty obvious, but I suppose they're not obvious enough that we should kind of give them their own video.